Hello, sir. This is my graphics project. I'm Mauryavardan Reddy, registration number 19BC1533. My topic of the project is Snake game using computer graphics and microcontroller. Introduction of the project. Snake game is an ideal computer game in which we control a snake to move around and collect food in a map. In this project, we tried to develop a controller using artificial intelligence by using movement rating functions and evolutionary algorithms. So before elaborating how to design the controller, the snake game which is implemented and the objective defined will be explained initially. In the game, the snake is allowed to pass through all the area around a two-dimensional playing field, that is the LED 18:8, and the game map which is surrounded by not walls. We removed the walls because of due to it is a lesser area actually. When we see in the displaying thing, yeah, I might say 18 to 8 is a very good display thing. But when we are playing the game, it is a bit smaller. So for that, I removed the walls and I gave through access through the snake through the walls. At each distinct interval, a time step, the snake should move forward, or turn left, or turn right, as the snake requires, and the snake cannot stop moving. And the game will be generated randomly, and a piece of food sorry, will be placed anywhere in the map. That is coded by me only. I gave the random number command in there, and wherever there is no food on the map, then the snake moves towards the food, and if the food is eaten, then the length of snake will be increased by 1. And the goal of the game is to eat as many food without getting collide or by itself. The objective of the game is to maximize the score. The above mentioned simple strategy may keep the snake alive, but without moving towards the apples efficiently, it cannot get a high score. Your apples itself are full. So thus it is needed to be designed with more intelligent controller, which is the further topic. Let's discuss there. Hardware requirements. So these are the hardware components we're using in this project. The first one is Arduino Uno. This is the motherboard of the circuit. And the second one is 18:8 LED dot matrix display. And the third one is breadboard and jumper wise, which is used for circuit connection. And the joystick, which is used for the movements and everything. And the potentiometer to adjust and control the voltage. So coming to the graphics and multimedia requirements. So here we have joystick. So the joystick give values along the X and Y axis, and it also contains two potentiometers, one for each axis. The two potentiometers allow us to measure the movement of stick in 2D. The potentiometer is basically a variable resistor. As we move the joystick, the value of resistance of the both potentiometer changes. So this change in turn gives us values along the X and Y axis. As you can see in the screenshots here, this is the code, this is the analog read command we gave here. So that gives us the values of the X and Y axis. And this is the second screenshot of the output. So here's the another graphics and multimedia requirement, the dot matrix. A dot matrix is a two-dimensional array of dots used to represent characters and images. Typically, the dot matrix is used in older computer printers and many digital display devices. So, and a dot matrix display is a display device used to display information on missions, on railway departure indicators, and many and other devices requiring a simple display of device of limited resolution. So, the display consists of a matrix of lights or mechanical indicators arranged in a rectangular configuration. Other shapes are also possible, although not common, such that by switching on or off selected lights, text or graphics can be displayed. A dot matrix controller converts instructions from a processor into signals which turns on or off lights in the matrix so that the required display is produced. So that's why we're using dot matrix in our project. So moving to another graphics and multimedia requirement, frame buffer. It is known as a portion of memory reserved for holding the bitmapped image that is sent to the display device is called the frame buffer. And that area is as we discussed, a memory area called as a frame buffer or refresh buffer stores picture definition. This memory area holds intensity values for all the screen points. So each screen point is referred to as pixels, which we will discuss a bit later. In the systems, refreshing rate is done at a rate of 60 to 80 frames per second. And modern video cards contain frame buffer circuitry in their cores also. So here you can see the diagram of this frame buffer, the picture information. So it directly, like the whatever the commands 1 zeros is there, the ones are glowing here on the screen. So as we discussed earlier, as the image depicts that if information stored in the frame buffer is 1, then the corresponding pixel is made bright on the screen, and if it is 0, then no brightness appears. That is, 0 equals to off and 1 equals to on. So the image obtained on the screen is discrete. So this is the outcome of my project, which I used this condition for this. And this is the video explanation for this. So the next one is pixels. A pixel is the smallest unit of a digital image that can be displayed and represented on a digital display device. So this is the basically logic unit in the digital graphics. Pixels are combined to form a complete image, video, or text or any visible thing on a computer display. As you can see in this picture, this depicts picture element on a pixel and the address point. So we know that a pixel is represented with a dot or a square on a computer screen. So actually, what this helps in our project is that I can give the position or coordinates of the light exactly where I want by this thing. By the help of this frame buffer and the pixels, we can give the exact position where we want to the light to be glowed. So the ideology for snake algorithm. So what I thought was, in this game settings, the game map will be 8 units high and 8 units wide, which consists of 64 available spaces. So the snake at first will begin at the top left corner. First I thought, but later I gave that a random thing because that makes user more effective gaming play and facing towards right. So with an initial length of 4 units, because therefore the snake can eat not more than 60 pieces of food before filling up the entire map. This is just some combination progressions I used for getting to know how much time a snake can survive in this everything. So this is the ideology for snake algorithm, and as you can see in the video right now. So coming to the snake movement algorithm. So here you can see some methods are, the first is path solver. So some methods are provided to find the shortest path and the longest path from the snake's head to the other points on the map. For the shortest path, the breadth first search is used by the path solver to find the shortest path along the map. And when it is the longest path in the playing field is NP hard. The path solver uses the heuristic algorithm to find the suboptimal solutions. And moving to the greedy solver. So what is greedy solver? The greedy solver will make the snake to eat the food along the shortest path. So if it thinks that particular path will be safe for the snake to eat, otherwise it makes the snake to move around until it finds a safe path. Since it needs a path searching, it depends on the path solver. And coming to the Hamilton solver. So initially, the Hamilton solver builds a Hamiltonian cycle on the playing field and then directs the snake to eat food along the path. To reduce the average steps the snake takes to success. It enables the snake to take shortcuts anywhere along the map if possible. This Hamiltonian solver also depends on the path solver. So these are the two things which I developed. The controller which we talking about earlier, these are the controllers we developed. So these are the results I got while implementing this. So the first one is greedy solver results. We can see it directs the snake to eat the food along the shortest path if it thinks the snake will be safe. Otherwise, the snake will be move around all area around the playing field until it finds a safe path. So this depicts that main objective is to win. I mean, as soon as you complete taking all the food in the area, then you will be the winner. But what this makes is, if the path is not safe, it doesn't find to the shortest path. It moves all around until it finds the shortest path. So that's the drawback here. And moving to the Hamiltonian cycle. So the results are the Hamiltonian cycle works only when the initial positions of the snakes and head bodies are similar to the situation when the point like 0, 1 and 2, considering the initial head of the snake bodies are 2, 1, 0 respectively. Then make the point 1 to be unreachable and generate the longest path from 2 to point O. So finally we joining the starting point 2 and the ending point 2, which forms a Hamiltonian cycle. So basically what it does is it takes the head and the body bottom of the position and makes that there would be no contact and make sure that there would be no contact to those 2 points. So that makes us snake never dies, but not as a winner. So by this thing I concluded the manual thing would be the best with using the joystick. So I moved forward with the manual joystick thing. So in the snake algorithm, we used snake parameters, which contains how the snake, the length and everything, and the for direction use, and the code for the foot, and the for snake movement and direction, and the game over conditions, like what not to be done in the game while you're playing, and what if snake goes beyond the LED, and the joystick controls. So these are the main factors and the components that make this project successful. And the code for these components I have given in the final report. So I guess so by that I'm not sharing the code here again. So this is the final output of the project. So till now whatever I have explained and the components I have used, everything's working here, you can see. So yeah, this is the final output of the project. Coming to the result and inference. Personally speaking, I'm much more satisfied by the results I've got. Because in this project, I can see the game start with the 4 units and can go up to all the way 60 by doing the foot. So that find users may be challenging and everything. And I included the positioning and coordinating the lights foot and snake movement and also frame buffer pixels and the movement algorithm. These all the things made this possible to move forward for the game. And also possibilities include automated navigation of multiple robots through a crowded workspace and automation for fleeing police suspects through harsh environments. I mean, these are the basic, as for the results, these are the inferences I just wanted to include here. So when it comes to the future work, these method of doing projects like combining with different courses will surely give us a niche in the creativity level So obviously we do not worry about the future work because this work presented in this report provides innumerable opportunities for further investigation, like into the evaluation of the task prioritization scheme within a dynamically changing and randomly updated environment, like giving more forwards and more obstacles. We can include that, and also multiple snakes could be co-evolved to complete to competitively, pursue the food. And actually, basically, I was working on the console. I wanted to build a basic console out of it, but due to some unfortunate conditions, I couldn't because of this pandemic. So here's what I did as a protocol using Blender. So here you can see in the Blender, I gave the breadboard, display, joystick, Arduino, and the components what I have used here. And I made a protocol using this console. These are the two red and black are the buttons. So I made a cardboard down below and I gave Arduino here. So, but I couldn't make it because of the COVID. So this is my future work. So finally, conclusion. I can proudly say I have pursued the knowledge of embedded system design after finishing this project and obtained more experience of hardware and software co-design and more likely to think of the embedding different scenarios and different subjects together since it was the first time that I built an embedded system like using a real life application where we know all this came and combining the microprocessors and graphics multimedia. So a lot of problems were encountered during my work on this project. Like for the software part, it took me a long time to familiar with the movement algorithm and coordinating the points for the lights and the FURD, like where it has to display and without colliding each other. And the microcontroller, 8 into 8 LED dot matrix, joystick, Arduino, and some other components used in this. And for the software part, we test our program by applying embedded C and simulated using Arduino IDE. So by this, the final product is ready in use. So this is what I would like to conclude in this, in my project. Thank you, sir.